So one of the things that students typically have some of the most difficulty with in any intro astronomy class is understanding how the motions of the bodies of the solar system work. In particular, how do we observe the motions of the Earth and of the Moon from here on Earth? So let's just look at the Earth's spin as an example. So we have the Earth here. We've already gone through this, but we know that the Earth spins on its axis. And in particular, we know that it spins in the counterclockwise direction. So it goes about its axis in the counterclockwise direction from above. So if I'm up above here, I'm seeing the Earth go in the counterclockwise direction. And let's see how exactly we could determine that. So let's look at North America here. Here's North America. There is roughly New York. It's tough to do here. There is roughly New York. There is roughly Minnesota. And there is roughly California. And let's watch those three things as they rotate around the Earth. So for the rest of this, you're going to be the sun. Your view from right there is going to be the view that the sun would have of the Earth as it spins around its axis. And let's just see what the sun sees. So everything you're seeing here as the Earth goes around counterclockwise, you're seeing the daylit side of the Earth. You're seeing North America go by. 12 hours later, you're seeing Asia, and then Europe, and then 12 hours later, again, North America. So now North America is just beginning to come up here. Now let's see what you as the sun would see. So I have my finger on New York. The first part of North America that you're going to see is New York. It's a little tough to see because of the glare, but you would actually be seeing New York as it rises as the Earth spins. So there's New York coming into view. Now you will be beginning to see Minnesota coming into view here. Finally, you begin to see California come into view. At this point in the middle of the day, you're seeing the entire continent of North America here. And so North America, someone in the middle of North America, right about there, would say that it's noontime. Now watch what happens as the planet continues to spin. Here's New York. New York is the first part to go out of view here. So New York is no longer in the daytime. Now Minnesota, which is right there, you can still see Minnesota up until right about now. So the sun is set in Minnesota. Finally, California is still slightly in view. Now the sun's set in California. Now it's entirely nighttime on North America. Go forward again. Here's New York just beginning to get into view here for you, I think. Now here's Minnesota beginning to get into view. Now there's California beginning to get into view. And again, rotate around, nighttime. So the first thing you see from the sun's point of view is North America. But what does that mean for us here in Minnesota? So here's Minnesota, roughly. And as the Earth is just beginning to, as North America is just beginning to face the sun, if you're in North America right now, in order to see the sun, you would look in this direction, meaning that you're looking from Minnesota to New York to the sun. So you look towards the east to see the sun. As the Earth spins, now you don't have to look to the east anymore. Now you're looking straight overhead at noontime. But as we spin a little more, as North America just begins to see the sun going over the other horizon, now you're looking from Minnesota to California to the sun. Again, Minnesota, California to the sun. So you're looking to the west to see the sun set. Same thing. Minnesota, you're looking towards New York to the east from where you are. Now you're looking to California to see the sun set to the west. Again, this is all due to the fact that the Earth goes around in the counterclockwise direction. To see the sun setting, we're positioned like this, so we're looking to the west. To see the sun rising, we're positioned like this, looking to the east. So let's try this in one other way, in a way that makes me look a lot stupider here. So I have these, I always love doing this, I have these little signs here. This is showing which direction is east for me. This is showing which direction is west. And I'm going to spin around just like the Earth, and you're still going to be the sun. You're going to see what part of me is visible, what part of me is not as I spin around. So, again, eastern direction for me, western direction. And again, I'm going to spin around the counterclockwise direction. You're the sun there, so I'm just spinning around like this. You're seeing my western horizon. Now here is my eastern horizon. Western horizon, nighttime for me. Eastern horizon, daytime for me. So, when the sun is not in view, it's nighttime for me. But here, right as I'm just barely beginning to be able to see the sun above my horizon, I have to see the eastern horizon. I have to look to my east to see the sun rising above the east. As I turn a little more, the sun is straight overhead. It's illuminating me directly. As I continue to spin more, now I'm seeing the sun getting closer and closer to my western horizon. And at this point, the sun is just barely above my western horizon, and blip, it's nighttime. Now again, I have to look to my eastern horizon to see the sun rising. It's getting higher in the sky. It's at its maximum height in the sky. Now it's getting lower towards my west. And I can do this all day long, get really dizzy. But what happens if the Earth is rotating in the opposite direction? If instead of going in the counterclockwise direction, what would happen if the Earth is going clockwise? How would that be different for us? So let's check that out. Same thing, eastern horizon, western horizon, but this time I'm going to go this way, clockwise. So watch what happens now. To see the sun beginning to rise, I now have to look to my west. Sun's getting higher. Now the sun is at its maximum height. It's getting lower towards my east now. And now I have to look to the west to see the sun rising. I have to look to the east to see the sun setting. Same thing. So, the point is, if the Earth rotated in a counterclockwise direction, if the Earth is like that, then I look to my east to see the sun rise and my west to see the sun set. But if we're going the other direction, clockwise, it's exactly reversed. In that case, we would see the sun rise in the west and set in the east. So, kind of cool. And that's how we know that the Earth actually rotates in the clockwise or in the counterclockwise direction. Because the sun sets in the east and it rises. No, because the sun rises in the east and it sets in the west. So, hope that helped.